Hi, today we're going to talk about using scientific notation in word problems. So, for example, we might have a word problem that looks something like this. The mass of the Earth is 5.972 times 10 to the power of, that's what that little, it's called a caret, a little arrow symbol means, is to the power of 24 kilograms. The mass of the moon is 7.348 times 10 to the power of 22 kilograms. Those are both true, by the way. I looked them up. So then we might have a question. In fact, there's lots of different questions we could ask about this. First question we could ask about this is, what is the combined mass of the Earth and the moon? Well, combined mass just means we're putting them together. So when we're combining, we're just going to add this number plus this number. Now I'll tell you, whenever I'm typing these in the calculator, I always put parentheses around each scientific notation number because sometimes parentheses don't matter for scientific notation operations, and sometimes they do. And if you forget on the one time that it does matter, then it totally screws up the problem. So it's better to just get in the habit of always having those parentheses. Then you don't have to worry about if you were supposed to or not. So parentheses 5.972 times 10 to the power of 24, close parentheses, plus parentheses 7.348 times 10 to the power of 22, close parentheses, equals. So when we're combining, if it's a combined mass, we're combining two numbers, it's just adding them. And that happens to equal 6.04584 times 10 to the power of 24 kilograms. So that's the combined mass of the Earth and the moon. So that's one type of problem we might have. We might have another type of problem that says, how much larger is the Earth than the moon? Well, that's just saying like how much bigger it is or how much more mass is there. So in that case, we're going to subtract the bigger number minus the smaller number. Now, 5.972 looks like it's smaller than 7.348, but we need to look at the exponents here. This is to the power of 24. That means we're moving our decimal 24 spaces. This one is to the power of 22, which means we're not moving it as far, which means there's not as many zeros, which means it is not as big of a number. And we can kind of think of that too. It makes sense. The Earth is bigger than the moon. That does make sense. So it makes sense that the number for the Earth should be bigger than the number for the moon. So then we're just going to subtract parentheses. So let me start over. What I would type in my calculator is parentheses 5.972 times 10 to the power of 24, close parentheses, minus, because we're figuring out how much more of the Earth is there than of the moon. So we have to take away the size of the moon and see what's left over. So minus parentheses 7.348 times 10 to the power of 22, close parentheses, and that equals, when you subtract it, I'm looking over here because I have all the answers written down, 5.89852 times 10 to the power of 24 kilograms. So honestly, taking like the moon, that didn't take a big chunk out of it, right? The exponent's still the same, still starts with a 5. Like, it's just this little bit that changed. So it did not take a big chunk out of the Earth. Interesting. Okay, the third thing, this is a very common one. Now listen to how I phrase this. How many times larger is the Earth than the moon? I want to write out these two different questions. So number 2 was, how much larger is the Earth than the moon? And number 3 is, how many times larger is the Earth than the moon? So the key word there for this one we're doing right now, number 3, is the how many times larger instead of how much larger. So how many times larger? That's kind of like saying how many times can I fit the moon into the Earth? So whenever we have this, how many times larger, we're going to actually divide the bigger number divided by the smaller number. Okay, so we're dividing the mass of the Earth divided by the mass of the moon. This is where you do have to have parentheses, or else it's going to follow order of operations, which is going to screw up the problem in this case. Okay, order of operations actually worked beautifully for adding and subtracting. So the parentheses weren't as important there. But order of operations does not work quite so beautifully with divide, so you have to have those parentheses there. When you divide the Earth, mass of the Earth divided by the mass of the moon, we then get, well, it's actually a long decimal, but I rounded it, 81.3 times larger. We could write that in scientific notation if we want to, 8.13 times 10 to the power of 1. That really means that we could fit the moon into the Earth 81 times. Kind of crazy. And so we've done add, subtract, and divide. So, makes sense that the last one we're going to do is some multiplication. Now, with multiplication, often the type of problem we're going to have is something being repeated over and over again. Okay, well, the mass of the Earth and the mass of the moon is not something that happens over and over and over again. That's just a fact. Just is the mass of the Earth. It's not like, here's the mass of the Earth, and it's duplicating itself, right? That's not what's happening. So I'm going to come up with a slightly different problem for this, and it's going to still relate to the Earth. It is that the Earth rotates at 1 times 10 to the third miles per hour. That's real. I looked that up. Then that's a fact. So then a question we could be asked is, well, then how far does it rotate in, and we could choose any amount of time. In my example, I'm saying in 3.2 times 10 squared hours. So like, how far does it go? How much does it rotate in this many hours? Well, all we do is we multiply these two numbers together. And when you multiply those together, you get 3.2 times 10 to the 5th miles. So in that many hours, okay, let's be honest, 1, 2, that's 320 hours. That's a lot of hours. But in 320 hours, it actually travels 320,000 miles. Pretty cool.